Namaskar, Adab, Sat Sri Akal. Welcome back, students. So we were discussing about Coulomb's law, and we have seen some example of integration kind of question. If there is some non-uniform body, some rod is there, and due to that, if you have to calculate electrostatic force, how you will do? We have discussed about that. Now, the next topic that we are going to discuss is about electrostatic equilibrium. Now, first time where you have listened about equilibrium, remember the topic work, power, energy. Correct? Work, power, energy, you have studied about equilibrium. What you have studied there, I will quickly recap that also. You know that from equilibrium you are studying from Newton's law, and the basic meaning that you understand from equilibrium is net force should be equal to 0. So if I am talking about electrostatic equilibrium, what I will say, the net force acting on any charged particle in the system will be 0. Some more things we have studied there about the condition of equilibrium that we have generated, that du by dx is also called as force, and then we have made it 0. Now there are three kind of equilibrium that we have studied. What are those three kind of equilibrium? Stable equilibrium, unstable equilibrium, and neutral equilibrium. Do you remember that what kind of curve was coming there? Because here also some good questions will discuss about the nature of equilibrium. Let's suppose potential energy versus x curve I have drawn, and I have drawn somewhat like this kind of curve, for example. And let's say suppose I will take some points A, B, C, D, E and F. Correct? I have drawn some curve, and now I will ask you, tell me how many points of equilibrium are there, and if those points are, what kind of equilibrium are there. So you tell me how many kind of equilibriums. Firstly, tell me how many equilibrium points are there. Firstly, what you have to generate the condition that du by dx is equal to 0. How will you find du by dx? It is a u versus x curve. That means, can I say slope? If slope is equal to 0, force will be equal to 0. Correct? Now see where the forces are 0. Point A. How will you calculate the slope? This will be the slope. Can you say the slope for this line will be what? You know, tan 0 is equal to 0. Slope for this line is 0. Slope for this line is non-zero. This line 0. This line 0. This line 0. That is how many equilibrium points I am getting. Correct? 1, 2, 3, 4. I can say point A, point C, point E and point F. All these 4 points are what? My equilibrium points. Now the question will be coming, next question, that how many stable equilibrium points, how many unstable equilibrium points, and how many neutral equilibrium points will be there. So how will you judge it? I've always told the students to have a very simple method to judge what are the kind of equilibriums you are having. Take a ball and keep it here. Correct? You have taken a ball and keep it at the equilibrium point, and now displace it little bit right and little bit left. Correct? If the ball will be having the tendency to again come back at its original position, it will be what kind of equilibrium? It will be called as stable equilibrium. What kind of equilibrium, students? It is stable equilibrium. That means if I will talk about this point, if I am displacing it little bit right, can you say again it will be try to come at the original position, mean position. If I am displacing it little bit left, again it will try to come at the mean position. That means, can you say this point is behaving like what? Stable equilibrium point. Correct? Now check for this point. What will happen if this ball will be little bit displaces about in the right? What will happen? Does it ever come back at the original position? No. That means what kind of points, what kind of equilibrium points we call it as? We call it as unstable equilibrium. We give name for this kind of points as unstable equilibrium points, in which the body will not come back at its original position, is called as unstable equilibrium. Now next point. Point E. Which kind of equilibrium? Again, can you say it is stable equilibrium? Okay. Now point F, it is the last point. Let's suppose you have kept a ball and now what will happen? Again, as these kind of neutral equilibrium. Called as neutral equilibrium. So these are some basic types of equilibrium that you should know. Now let's see what kind of questions that we will be getting in equilibrium. Now see, the first case that we are going to discuss. Read what is the condition is saying. 2 point charges Q and 4Q are separated by a distance L as shown. Okay, a diagram is given. Where should a third charge capital Q should be placed so that it is an electrostatic equilibrium? So that it will be an electrostatic equilibrium. Okay. Now see, the question is asking you where in between, where you will place, or at any position where you will place, so that then complete system will be in electrostatic equilibrium. Correct. Now see, the charge q can be in equilibrium when net force acting on it is 0. Correct. It will be in equilibrium when the net force acting on it will be 0. The net force will be 0 when two equal and opposite forces acting on it. These are some basic conditions. Let's analyze one by one. What are the possible conditions? Okay. Where are the possibilities to get? Let's suppose this is the first condition. Now see. Case 1 is possible if charges q is positive. If charge q is positive, this one is positive, this one is positive, and you have made this charge. Correct. Wait. This was your original charge q. This is your second charge 4q, and now you have kept this positive charge capital Q that you have to find the position at three different positions: at position 1, at position 2, at position 3. Correct. And now you want to find where will be my actual equilibrium point possible. Firstly, you have to find possibility. All three possibilities I have brought. Now let's analyze one by one which possibility is there. Firstly, let's see at position 1. Position 1, what you can say? Let's suppose this is your charge q. Tell me, due to this small q, what will be the direction of force? What I have told you, positive, positive repel each other. Repel each other. This is a small charge q. This is capital charge q. What kind of force you will have? Repulsive force. Due to this 4q and this capital plus q, what will be the direction of force? Can you say it is also away from the body? Then tell me, is it any time possible that net force will be equal to 0? No. Why? Two vectors are in the same direction. That means there is no possible. No value can be possible to make two vectors in the same direction as 0. It doesn't matter whatever the magnitude. Some magnitude is there. Let's suppose if you are writing these two. Let's suppose the values is 2 and the value is 3. What will be the net value of this vector sum? 5. So is any possibility that you can draw that two vectors in the same direction and you can make net force equal to 0? No. So this point is actually not possible as equilibrium position. Now let's analyze this one. Now see this one. Let's suppose you have kept the charge at this point plus q beyond this 4q. Now let's analyze one by one. Due to small q, what will be the direction of force? Away, repulsive force. Due to 4q, what will be the direction of force? Again it will be away, same charges, repel each other. Now tell me, can net force is equal to 0 is possible at this point? No. Net force is equal to 0 is not at all possible. That means this point is also not of our use, because we have to find what? Equilibrium point, and for equilibrium point we have to generate a condition for net force is equal to 0. Okay. Now let's see for this one. If I am putting in between 4q and q, let's see. Due to q, what will be the direction of force? Repulsive force, that means away. Correct. And due to 4q, it will be again away. Now you will see one force is in positive direction, one force is in negative direction. Correct. Now there will be possibility, only possibility. Still I am not saying that it will always be 0. Still we have to create a condition somewhere in between this complete distance. There will be some point where you will keep this capital Q, and then you will be having your net force is equal to 0. That is the latter part of this question. We will see. This was a case 1. Second case, let's suppose also analyze for we will covering all the varieties. Let's suppose what if your charge is minus, negative. Okay, then what will happen? This was your first position, this was your second position, this was your third position. Now this time you can able to analyze the situation. If this is negative, this capital charge is negative. Due to this small charge q, what will be the direction of force? Can you say negative charge, positive charge, attractive forces? Attractive forces means direction will be like this. Due to capital 4q, what will be the direction? This is negative, this is positive. Can you say again attractive? Two forces in the same direction, is it ever possible that net force will be equal to 0? No. That means this position is not possible. Same I can say for position 3 also, it is not at all possible. Equilibrium is not possible. Now let's analyze for again the middle case, in between charge q and charge 4q. Now when I will draw, due to q, this is positive, this is negative. Correct? Which kind of forces? Attractive forces. That means can I say this is the force? Correct? Due to q. And I can say similarly, same way, this will be the force, that is 4q. Can I say again the position 2 is becoming my possibility for making net force is equal to 0. Correct? So from here we have analyzed, we had a very good idea that which positions are actually will be able to make net force is equal to 0. Now let's see about the values. Now let's solve it. What was the conditions that we had? There was a charge q. Sorry. There was a charge q. There was a charge 4q. Distance between them was L, and what I have to do? I have kept a capital charge q somewhere in between. Now this is clear why I am keeping this in between, correct now? So let's assume some distance x from here. I am keeping from distance x from here, and that means what will be this distance? I can say simply this will be simply my L minus x, because total length is L, correct? And what I am saying that this situation is in equilibrium, that means I can say whatever the net force that is applied due to both these are equal to 0, correct? Now let's draw the vector diagram also. Let's see what is the vector diagram coming. Due to q, what will be the direction? I can say this will be the direction due to q, and due to 4q, again same kind of charges. I am taking this as positive charge, that means I can say this will be the force due to 4q, and I can say that this force due to q and this force due to 4q have to be equal to make it net force is equal to 0. Let's write what is the force. Force due to q, force due to q, what will write? What is the formula? K q1 q2 divided by r square. K q, capital Q, divided by what is the distance between them? X square is equal to. Now what is the charge due to 4q? Force K q capital 4q capital Q divided by. Now what is the distance between them? L minus x whole square. Correct? Can you write this? Now simply see, this complete thing can be cancelled out. Now take better way of solving this is always to take this denominator in the numerator here. What then you can say L minus x divided by x square whole square will be equal to 4. Next step, how you do? Remove this square, and what will be left? L by x minus 1 is equal to 2. That means also you can say L by x is equal to 3. That means x is equal to how much? I can say L by 3. Correct? So what is the position that I am getting where I am going to get the equilibrium? From this chart, I can say that x should be equal to L by 3, and from this one, what I can say the distance L minus L by 3, that means distance will be 2L by 3. Is it correct? This is the kind of question that will be coming in electrostatic equilibrium. From this very good example, I hope that the equilibrium concept will be very much clear to you. Okay. Here you can see what is the distance that you finally are getting. X is equal to L by 3. Now next thing is vectors, Coulomb's law in vector form. Coulomb's law in vector form. Let's see what is Coulomb's law in vector form. Now let's suppose for two charges some position vectors are given. Okay. Position vector of q1, this is q1, this is q2. R1 is given as position vector of charge 1, and R2 is given for the position vector of charge 2. Correct? Position vector of q2 with respect to r1, what you will say? That means what you want to write r vector, and r vector can be written as what you are writing position vector of 2 with respect to 1. That means you are writing r2 comma 1, and how you will write r2 minus r1. This thing you already studied in vectors. Okay. Now what you want to calculate, basic meaning of writing all these things is to how to write vector form of Coulomb's law. This is the sole purpose of writing all these things. So how you will write? You remember, for writing any kind of vector, what are the two things that are required for you? What are the two things? First thing is magnitude, second thing is direction. Correct now? So if I will ask you, tell me what is the magnitude? Can you see you have already studied Coulomb's law? We have applied lots of formulas. What is the magnitude part? K q1 q2 divided by r square. Correct? Now we have to worry only about the direction. Let's see how we can find direction as well. Now see, if I want to write, now there can be two possibilities. What is the direction of force on q2? I can write this as force on 2 due to 1, and I can write this as force on 1 due to 2. Correct? This will be the direct, because same charges, that means repulsive force. And let's suppose I want to write, because you know I already have told you that directions are opposite, but the magnitude wise they will be exactly same. Force on 2 due to 1 is equal to force on 1 due to 2. Now let's write. This is the r vector. Okay. Let's suppose I want to write force on 2 due to 1. correct? I want to write force on 2 due to 1. So how I will write? I will write firstly magnitude part, and then I will write the direction part. Simply for writing any kind of vector, these are the two basic things that is required. Magnitude part is also, I know already, it is what? K q1 q2 divided by r square. R square is what? The your final vector square. Now interesting is what you will write for the direction. Tell me students, what was the use of unit vector? We have studied unit vector, that I have told you that it is very important. Unit vector always we use for directions, and how directions are taken? We use a cap. So what I will do? I will use a r cap. Correct now? R cap means, and R cap can also be written as, that means same. This is the standard result, that is standard way to write Coulomb's law in vector form. So it is also written as K q1 q2 divided by r square into r vector divided by magnitude of the given vector. I hope that this formula is very much clear to all of you. So also it can be written as K q1 q2 divided by r cube into the given vector, that is r vector. This is the net force. Clear? This is the way how you will represent. Okay. So let's solve a question so that you will have a better understanding of writing, how to write the vector form. Okay. Now what is the given into the question? Let's firstly see the question properly. There is a 2 coulomb charge. There is minus of 5 coulomb charge. Correct. Positions of coordinates are also given, 2, 4, 5 and 4, 5, 7. Okay. Now the question is asking, find the force on minus of 5 coulomb charge at Q. You have to find what will be the force that will be acting here. How will you do? Firstly, draw the directions. If I am asking you for this force, can I say this will be an attractive force? This is force on Q. Correct? Force on Q. Okay. So how I will write? I will write simply what? Firstly, take what is the charge it is mentioned here. Tell me what is the position vector of P. What is the position vector of P? What are the coordinates? 2, 4, 5. How will I write the coordinates? Position vector 2i plus of 4j plus of 5k. This will be the position vector of Q. Now tell me what is the position vector of Q. This is the position vector of P. Position vector of Q, if I have to write 4i plus of 5j plus of 7k plus of 7k. And what I have to write? I have write force on Q due to P. Correct? How I will write? I will write the magnitude as well as direction on on Q due to P. So if I have to write position vector of Q with respect to P, that is R vector, how I will write? I will write R Q minus of R P vector. Correct? You can represent this also as R Q comma P. A lot of places it is represented like this. Now tell me R Q minus P. What you will write the vector form? Q minus P. Q minus P, that is 4 minus 2, 2i, 5 minus 4 plus j, 7 minus 5 plus of 2k. This will be your R vector or R Q comma P vector, whatever you want to represent. Now let's write the net force. Net force can be written as force on Q due to P. It will be written as K, that is also written as 9 into 10 power 9 into Q1. Q1 is 2 coulomb into Q2, that is 5 coulomb, divided by what is the distance between them, or vector, what is the vector? 2i plus of j plus of 2k. If I will ask you, tell me the magnitude of R vector, how you will write? Root under 2 square plus 1 square plus of 2 square, that means you can say root under 9, that means finally the value will be coming 3. And you know that here will be the magnitude of 3 and here will be 3 square, that means this distance R is equal to how much? 3. Now finally how much you can say? This 9 will be cancelled, this 10 will be there, that means here it will be 10 power 10 divided by 3 into 2i plus of j plus of 2k. Correct? So this will be the final way. This is now complete your magnitude part, and this will be finally your direction part. And combined way we call it as vector part. Correct? Same thing we are writing, just we have to know the little bit idea of position vectors, then you can easily solve this kind of questions. Okay. Now next thing and the final thing that you have to understand in Coulomb's law is when what will happen, I told you about permittivity in the last lecture. If you'll say, we have discussed little bit about permittivity. Now we will discuss in complete depth how we write. It is very easy, just understand. What will happen if you are inserting any kind of thing into any medium? Okay, there is a term that was k is equal to 1 by 4 pi epsilon naught, and that epsilon naught was what? Permittivity of free space. Permittivity of free space. So let's see what will happen. Let's suppose initial condition is what? When we asked to force Q1 Q2 only in vacuum. In vacuum it is very easy. From that much time we are writing this thing. In vacuum, how you can write force as K Q1 Q2 divided by epsilon, and K can be written as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. But now what will happen if I am taking this complete system into some liquid? That means now at the place of epsilon naught I will use epsilon. Epsilon is the permittivity of medium. So what is the change? Eventually it is going to come. There is not a lot of changes. Simply what I told you there, if you remember, relative permittivity is defined as permittivity of medium divided by epsilon naught permittivity in vacuum. This is the basic definition. So if I have to write force in a medium, how I will write? I will write K Q1 Q2. Actually at the place of K I should write 4 pi epsilon because we are going to use that. Correct now? In a medium, I will write 1 by 4 pi epsilon divided by R square. Now at the place of epsilon, what I can write? I can add from here, I can multiply epsilon naught and what I can write? See properly, Q1 Q2 divided by R square 1 divided by 4 pi. At the place of epsilon, what I will write? Epsilon naught into epsilon R. Now please look carefully what I can say. And what is this epsilon R? Relative permittivity. It will be always given to you. What is this 1 by 4 pi epsilon naught Q1 Q2 divided by R square, this complete term? Can you say it is nothing but the Coulomb's force that is present in air or in vacuum? Correct. So I can say this is the force in air divided by what is that? Epsilon R. This will be a force in a medium. Very simple thing. Just remember that whenever you have to write any kind of Coulomb's force in any kind of medium, if it is given, just simply write the force that you know already, 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, and then what you will do? Just simply divide it by epsilon R, and what is epsilon R? Relative permittivity, and that's it. You don't have to do anything else. It will be automatically adjust its answer, because we have seen there is only extra factor that is coming, that is epsilon R. So why we have to worry that much? So take it, if it is easy, take it easy. Don't try to make it complicated. Correct? So this was about Coulomb's law, students. Now let's see about electric field. We have seen about forces, okay, but in the introduction part only I have told you about electric field. Let's suppose if this is a charge, what will happen? Why actually electric force is also coming? Electric force is also originated from electric field. What will happen if this is a charge? It will induce an electric field around it. Okay. For visual purpose, we represent it as electric field, electric lines of forces. These lines are called as this field that is generated around. You can see that here it is a positive charge and here it is a negative charge. There is a lot of reasons also why this is only going in this direction. We'll discuss that in a separate topic, but as of now we are just trying to have a feel. These lines are called as electric lines of forces. What we call these lines as electric lines of forces. Now these lines are actually nothing but electric field, okay, that is present around a charge. Whenever there is a charge, I have told you a lot of times, there will be all around in 3D diagram, there will be a lot of electric lines of forces that will be present there. Okay, so now what will happen? How this electric field was actually felt? Let's suppose if I am bringing any test charge into it. As of now, forget about this negative charge, only focus on the positive charge. I have brought a test charge, and let's suppose it is also positive. If I have brought into this electric field, what will happen? Correct? It will also feel some electric force, repulsive. If same sign are there, that means it will feel some repulsive force in the outward direction. Okay. So from there we have defined that, and as soon as you are coming closer to it, can I say my electric force will be increasing? The more closer you will come, the more electric force you will be feeling, or Coulomb's force you will be feeling. Correct? So this is the basic idea. If I am talking about the electric field definition, it is a region, I have told you it is a region around a electric charge which if any other charge is experiencing a force of attraction or repulsion. It is a region in which if you are introducing any other charge, like suppose we have introduced a test charge, it will experience an electrostatic force. Now it depends, either it will be attractive, either it will be repulsive. Okay, I will tell you also that how to predict the directions easily. Okay, so how electric field is defined? Now, here some theoretical things are given. How electric field is defined? Electric field is in numerical terms, it is defined as force per unit test charge. Force, electric field is defined as, this is the definition, represented as E. It is defined as force experienced by the test charge divided by the test charge. Correct? So let's suppose I have introduced a Q naught test charge here, and this is the source charge Q. Let's suppose represented as QS. How will I write? What is the force that electric field if I have to write? I have told you it is written as force per unit test charge. Tell me what will be the force that you know, and let's suppose this distance is nothing but R. Okay. You tell me what will be the electric field. K, Q, that is source charge, into test charge divided by R square, that is the distance between them, divided by test charge, test charge. So what you can say about electric field, what is the formula of electric field? This is the source charge divided by R square. That means what is the formula of electric field? It is nothing but KQ divided by R square. If I am talking about units also, what are the units you can say? Units can be written as force per unit test charge. Force is what? Newton. Charge is what? Coulomb. That means unit is what? Newton per Coulomb. Correct now? If you have to write about the dimensions also, can you write dimensions? Let's write the dimensions also. Because when you are understanding this thing, we should understand it completely. What you can write for dimensions? Dimensions is also easy. Tell me, in numerator what is there? Newton. Newton have the dimension of ml2t minus 2. What will write the dimension of Coulomb? Coulomb is, I have told you in the starting lecture, first lecture only, that it is nothing but equal to A into T. From here what you can write the dimensions also, it will be m L square as it is, T power minus of 3 now it will become, and A power minus 1. This will be the dimension for electric field. Correct? So these are some basic things that you can understand. If I am talking about the directions, for any point charge, test charge that you are bringing, always assume that you are positive. Let's understand by a question. Okay. It will be more clear to you. Here it is shown very beautifully. Same thing. It will become, electric field will be equal to KQ divided by R square, force per unit test charge. Okay. Now, if I am talking about how it is varying at the curve, I can say electric field is equal to how much? KQ divided by R square. That means if I am asking you about the, if I have to draw a curve between electric field versus position, how they are varying, I can say electric field is inversely proportional to R square. Correct? Inversely proportional to R square. R square means, that means it will be continuously, if distance is increasing, what is happening? Electric field will be decreasing continuously. So what kind of, let's suppose what kind of curve will be coming? If R is tending to 0, can you say here R is very small and tending to 0. If R is tending to 0, what I can say about electric field? Can you say electric field will be tending to infinite? That's why this value is tending to infinite. Correct? And when E is tending to 0, if E is tending to 0, can you say R will be tending to infinite? These are your 2 points, and this will be the curve that you will have. It will be continuously decreasing. Correct? This is always, remember, this is the curve for point charge. Okay. This is a very important curve also. And anyways, we'll see a lot of new curves also coming very soon to us. Now these are some basic things. Electric field is a force on 1 Coulomb charge. It will be same. Head. This is the directions. How to write the directions also, I will tell you. Let's suppose here is a positive charge kept. Here is a positive charge, and at the distance R, point P, I will ask you, tell me what will be the direction for electric field. Let's suppose I have asked you this question. Okay. So how will you predict now? You will assume you are standing here. Let's suppose you are the observer. You will assume that you are always positive. You are always positive. If you are positive and the source charge is also positive, that means what kind of forces? Repulsive forces. Same will reflect the direction for electric field. This will be the direction for electric field. Same as the direction for force. Let's suppose there is a negative charge. And again at a distance r, I am asking you what will be the direction for electric field. Tell me. Now again you will say what? I am the observer, I am standing at point P and I am always positive. If I am always positive, this is negative, what kind of forces will be acting? Attractive forces. Attractive forces means what will be the direction of that force? This will be like this will be the direction for attractive force, or I can say this will be the direction for electric field as well. Okay, force and electric field will be same direction. Here the dimensions are given, we have already written. Now don't get confused into I and A, both are the representation for current, ampere, or I is also representation for in-dimensional analysis for current. Okay. Now let's see from this question, you will better understand about how to apply the formula, how to find the directions as well. This question will be clear a lot of things. Okay. So let's see. Let's see. Now there are 3-point charges. Okay, what is the question? Firstly, let's read about it. There are two particles, each having a charge plus q, are placed on the two vertices of a equilateral. There are only two charges. This is first charge. This is second charge. Okay, and it is equilateral triangle. A distances are there of length a. Find the magnitude of electric field at the third vertex. Here you have to calculate what is the magnitude of the electric field. Let's see how we can do. Firstly, you have to find it. You have to draw the directions. Once you have learned about drawing the directions, now half of the job is done there only. If anyone is very good in drawing the diagrams in physics, nearly majority of the questions they can solve from only their brain. Okay. Let's see what is the direction on point 3 due to charge 1. Can you say it is positive? And what I have told you, that you will imagine that you are always positive. If you are positive, this is also positive. What kind of forces? Repulsive forces. This is electric field due to 1, correct? Now let's see for the second one. At this point, what you can say? This is positive charge. This is point 3. What will be the direction? Again, can I say repulsive? Because you are positive. This point is also positive. This is electric field due to 2, correct? Now let's write the magnitudes also. What is electric field due to 1? You will write k q square divided by, what is the distance between them? A square, sorry, not q square. Q square is the force. Let q kq divided by a square. What you will write? E2 you will write what? E2 you will write kq divided by a square, because the magnitudes are same. So can you say E1 and E2 are equal? So basically I have to do what? I have to resolve only two vectors which are equal to each other, and the angle between them is what? 60 degree. Is it a very tough job? What is the resultant? You will write E net, you will write root under E1 square plus E2 square plus 2 E1 E2 cos of theta. What you will write? E square, it will become 2E square plus of 2 times of E square into cos of theta. Cos of how much? 60. Cos of 60 is how much? 1 by 2. So can I say, if cos of 60 is equal to half, I can say this half and this 2 will be simply get cancel. What is left here? Root under 3e square. That is finally how much I will be getting? Root under 3 into e. So it can be written as root under 3 into e. E is what? K q square divided by, sorry, again I have written q. K q divided by a square, root under 3 k q divided by a square. The original answer that you are getting. So what are the methods? Again I am quickly recapping it. Firstly, show always the directions. Patiently draw the directions. Learn how to find the direction at any random point. Okay. Then once you have written it, then try to figure out what is the distance between them, what are the charges both of them are carrying, and just write the magnitude. And then the question will be left only for vector resolution. And I hope that you all are understanding very well how to resolve two vectors. Correct now? Now see, this is a curve that will show the variation if you are changing the positions, at what position what kind of electric field will be coming. Let's suppose this is plus q charge, and here it is again a plus q charge. What kind of curve will be coming? I am explaining this complete curve. Let's suppose you are moving little bit in positive direction from plus q. Please listen me very carefully. If you are moving little bit of in positive direction, what will be the distance from this positive charge? What will be the direction of electric field? Can I say it will be away, because it is same kind of charges. That will be because you are positive and this positive charge is also positive, that means away will be the direction. Okay. And what is the magnitude you always write? You write kq divided by r square. And can I say at this point r is nearly tending to 0? If r is nearly tending to 0, can I say electric field will be tending to infinite? And same I can say for negative direction, because here it is tending to negative of 0, little bit less than 0, that means electric field will be tending to negative infinite. Okay. Now what will happen? Now as soon as it is moving, it will reach some point, and if charges are equal, that means I can say exactly at the halfway, what will happen? This is the direction for electric field due to, let's name this is 1, this is 2, this is due to 1 and this is due to 2. So can I say at the halfway charges are equal, distance are equal, so can I say cancel out each other, that means what will happen? Electric field will be equal to 0 at the half distance, correct? Now after that what will happen? Let's suppose now you are moving here. One more thing, till here who was in majority? This was E1 and this is what? E2. On the left side who is in majority? Can I say the one who will be in majority will have the less distance, because it is inversely proportional to distance. So can I say electric field due to charge 1 will be in majority? That means positive direction will be having the higher magnitude. That means the resultant if I am talking, two vectors are there, that means resultant for sure, I don't know what is the exact magnitude, but it will always be in the positive direction till it is not become 0. In next section what will happen? In next section, if you will draw the directions, again if I let's take any random point, this direction, this point, okay, draw the direction, still it will due to E1, this will be 1 and this will be E2, correct? But now tell me who have the less distance from this charge. Can you say now E2 have the less distance, and if E2 have the less distance, it is having the higher magnitude. So can you say in this portion E2 is greater than E1, and if E2 is greater than E1, net direction of electric will be negative direction, and negative direction will be represented by a negative sign. Correct? That's why in this portion it is positive direction, and this portion it is negative direction, and again it will be finally tending to infinite. Okay? And same way for here also, it will be tending like this, and here already I have told you it will be tending like this, because once you have increased the distance a lot, that means again if you are increasing the distance a lot, electric field will be tending to 0. See, you can see that electric field will be finally tending to 0. Tending to 0, not exactly 0, but it will always be tending to 0. This is the complete curve that will be coming due to the changing by positions. Well, now it depends on the different questions, what kind of questions are there. Okay. Now here you can see for negative charge, just the directions will be reversed. For this one, what you can say? Exactly same things. I have already told you why it is tending to infinite, that thing is clear. I will just analyze these two portions. Let's suppose your point is at this point, this is point P. What is the direction? Let's suppose again name this is 1, this is 2. This is, now this time it will be attractive because it is negative charges, this will be due to 1 and this will be due to 2. Correct now? Now who is greater? Who have the less distance? Can I say E1 is less distance, that means E1 is greater than E2. That means what is the net direction of electric field? It is negative direction, and that's why you are having electric field as negative. What about the other section? Other section you can say, let's suppose a point here I have taken, this is negative, that means this will be E2, this will be E1. Now here who have the less distance? E2 have the less distance, that means what you will say, E2 is greater than E1. If E2 is greater than E1, what is the net direction of electric field? Positive, that's why you are watching that this is what? Positive curve also. Correct now? Now, electric field due to some continuous charge distribution bodies. Let's suppose till for point charges we have already understood. For point charges now we can easily write the things. But what about continuous charge distribution? Let's suppose a charge is distributed all over the body. Then what will happen? Correct? So we will see. For steps, what will be the steps I will tell you. Firstly, take an element. Simply forget about the complete body. Please always cut out an element and trust on the element. That element, if you are integrating from limits, correct limits, for sure you will be getting your result. Patiently just do it. Okay, because most of the students have the fear, I don't know why, for this integration. We'll see. Let's firstly analyze this question. Okay, question is, there is a length, L length of rod is there, and at a distance A from that rod at point P, I want to know what is my electric field. This is what I want to calculate. What I will do, first step is what? Please follow this step by step. You will be getting a result. Go at a distance x and cut out an element of thickness dx. And dx thickness will have how much charge? You know that lambda is equal to charge per unit length. So if I will ask you, tell me dq will be what? Lambda into what is the length that I have cut it out? Dx. This have to be clear. This have to be very clear in your mind. Okay. Now it is very simple. Now just forget about this complete rod. Just focus that it is a point charge. It is and here it is the point where you have to calculate. So what is the electric field? dE I will write small due to this small charge. What I will write electric field formula kq divided by r square. K dq is the small charge divided by what is the distance between them? X square. And limits of integration is important. Find a position. If I am standing here, what is the position of x? You will say 0. I don't want to integrate this one. I want to integrate from this point to this point. I want to integrate the complete rod, correct? I will add all these small elements from x is equal to. Tell me here, what is the position of x? Can you say x is equal to a? And here, what is the position of x? Here is x is equal to a plus l. So what are the limits I can say? It is from a to a plus l, correct? Now see what you can do. You will write k dq as lambda into dx divided by x square integration. After that, what will happen? Integration of x power minus 2, because rest of the things you can take out common from here. Let's do it in the next page, integration part. Okay. What I say, dE that we have written was k lambda into dx divided by x square integration of a to a plus l. Integration both the sides. This d integration will make it e, and right side what it will, k lambda, take it out of integration, x power minus 2 dx. What will the integration will give you? This will become plus 1 divided by minus of 2 plus 1. There is a negative sign that is going to come, and here what it will be, k lambda divided by 1 by x power a to a plus l, correct? Now minus of k lambda, just put the limits, 1 by a plus l minus of 1 by a, but there is a negative sign, so we are going to take that negative sign inside. So what you can say, k lambda 1 by a minus of 1 by a plus l. This will be your final result that you will be getting. After that, integration is very simple. Just patiently try to do it by yourself. Try it 2 times, 3 times. Eventually, you will be getting your results. There is no problem in it. Okay. We'll see some more derivations also further in this chapter. And the second one, that let's suppose now there is a vertical rod. Due to vertical rod, how you will integrate, this is even more interesting. Okay, let's see this integration. It will apply little bit good application of integration. Okay. Now let's see. Let's start. Just listen me carefully step by step. What is the first step I have told you? Take an element, because you know the results only for point charges, but there is a complete rod that you are having. Now what are the given things? Let's understand also. This perpendicular distance that is given, that is equal to, let's suppose it is d, but make it r, because more general it is represented as r. This angle from this vertical positive angle is given as theta1, and this negative angle, downside angle, it is given as theta2. Okay. What we will do, how we will take an element? We will go at a general angle theta, and we will cut out an element of d theta at a distance y from here. I will cut it out. Element. Okay. It will have some dq charge, correct? And it is what? Positive. Due to that dq positive charge, can you tell me what is the direction that is going to come? What I have told you, you are always positive. If you are always positive, can you say this is the direction for small electric field, correct now? And this was angle theta, that means it will have 2 components also. This angle will be theta. Now name these 2 components also. This will be what? dE cos of theta, or this, and this will be called as dE sin of theta, correct? 2 basic components. Now I can also say that this is what? Electric field perpendicular to this wire, and this is what electric field parallel to the wire, and I am going to separately solve both of these scenarios. Okay, let's firstly understand what you can write for electric field that is parallel to the body. What you'll say, you have to do integration of dE sine of theta, correct? Now tell me how you will write dE. dE is small electric field. What is the formula? K q divided by r square. Okay, K dq divided by r square. Can you tell me what will be the distance is going to be? This distance, what you can say for this distance? Can I say it will be root under r square plus what is this perpendicular distance? Y square. And if I am making this square, I can simply say it is r square plus y square into sine of theta integration. Correct? Now, wait. Now how we are going to proceed? How you can write dq charge also, because always lambda is given. Lambda is equal to what? Force charge per unit length. So if I'll ask you, tell me lambda, how you define lambda? Lambda can be defined as charge, total charge per unit length. So if I will ask you dq, how you write? Lambda into length. Length is how much? dy or dx length, whatever you want to say. This is some dx or let's dy, because we have taken in y direction, that's why dy. So how we will do this? We will write k lambda dy sine of theta divided by r square plus y square. Now math students will be knowing how to do this integration, or otherwise in PU2 you will learn this integration. How we do? We use a substitution method. What is the substitution method? We substitute y is equal to r tan of theta. That means what will be dy? dy will be equal to r sec square theta d theta. Now just replace this complete thing here. Take these constants out of integration and write just the remaining part. Integration. In numerator, what will write? Dy r sec square theta into d theta, and there is a multiplication of sine theta as well. And in denominator, what will happen? See, why you are putting r tan of theta is equal to, that means r square plus r square tan square theta. Take r square common out of here. R square common. What will be remaining? 1 plus tan square theta. What is 1 plus tan square theta? Can you say it is nothing but sec square theta. Correct? This will be the remaining part. Now sec square theta simply get cancelled. R and r square will get cancelled. What is left? K lambda by r, and only integration will be left for sine theta d theta. What will be the integration left for? Sine theta d theta. And what will be the limits of integration? That is also interesting. Limits of integration are, it is starting from minus of theta 2 to plus of theta 1, because this complete angle you want to cover. Integration limits will be minus of theta 1 to plus of theta 2. Correct? Now what is the integration of sine theta, students? Integration of sine theta is equal to minus of cos of theta. Limits will be theta minus of theta 2 to theta 1. Correct? Plus of theta 1. Now put the limits. What you will do? Cos of theta 1 minus into cos of theta 2. Correct? What you will write further? K lambda by r into minus times, and there is a minus of minus cos theta also, minus, and cos of minus theta, and cos of minus theta is anyways cos of theta. So can you say eventually it will become plus, and what will be left? Cos of theta 2 minus cos of theta 1 will be in bracket, and this is the electric field in the parallel direction. This is the result. First part of the result that you have to remember. This electric field that is coming parallel to the wire component will be k lambda by r cos of theta 2 minus of cos of theta 1. Correct? You can take screenshot for it also. Please try to solve, do it by yourself only, then only you will understand 2-3 times. Easy integration. There is nothing much complicated. You can see k lambda by, and here they have written d here, but mostly it is referred as r. So write r, k lambda by r cos of theta 2 minus of cos of theta 1. This is the one part. Now what about the second part? If you remember, now we have to integrate. Now it will be easier. If you understood the first part, I am doing here only. You remember this component was what? d cos of theta. That means now we have to integrate de cos of theta. Let's understand this also. I am doing here only in the left spaces. or if I have other space. Let's do here the second portion. Next portion that we have to find, electric field in perpendicular direction will be equal to integration of dE cos of theta. D, how you write? Small electric field. I have told you to, due to this effect, what you write? K, charge, that is dq, divided by distance. I have already told you it is r square plus y square into cos of theta. Integration. Now, how you will write dq? dq will be written as lambda into dy cos of theta divided by r square plus y square. Again do the substitution. Substitution, r is equal to what? Sorry, y is equal to what? R tan of theta, correct? Now see what? dy, differentiate this. Differentiation will give you what? R sec square theta d theta. Differentiation will give you this. Replace dy and take the constants out of integration. Dy can be written as r sec square theta d theta into cos of theta divided by, here again I will say the same thing, r square plus y square, and here y will be represented as r square tan square theta. Take r square common, what will be left? 1 plus tan square theta, that can be written as sec square theta. Can you say sec square theta? Sec square theta will simply get cancelled. This r and r square will also get cancelled. What will be left? K lambda by r. Integration will be left for cos of theta into d theta. Limits will be again minus of theta 2 to plus of theta 1, correct? Now integration of cos of theta will give you sine of theta. Limits will be minus of theta 2 to plus of theta 1. So finally result will be what? K lambda by r sine of theta 1 minus of sine of theta 2. Now minus of theta 2, this minus will be coming outside, and finally the result will be coming. Where should I write the result? Here I am writing K lambda by r of theta 1 plus sine of theta 2. This is what? Electric field in the perpendicular direction. There two components were there. This was dE cos of theta, or also we have represented this as parallel direction. This was the perpendicular direction to the wire, and the magnitude will be what? K lambda by r sine of theta 1 plus sine of theta 2. I have did the complete derivation in the proper descriptive way. I hope that it was clear. You can see here the result is also written. Perpendicular direction K lambda by r sine of theta 1 plus sine of theta 2. So this was about electric field. There are some more points about this that we will study in the latter part of this chapter. Till now I hope that it is clear. Endigo and then digo nama tapasya. Until next time, keep learning, keep growing with tapasya. Thank you.